Hello and welcome to the Mathematics 23 review. In this video, we will talk about conservative vector fields. So let's recall some terms. So we say that a vector field F is conservative if and only if there is a scalar field phi such that the gradient of phi is equal to F. Okay? So we can find a scalar field phi such that when we take its gradient, it's equal to the vector field F. And an important theorem that arises from this definition is that the curl of this vector field, this conservative vector field, should be equal to the zero vector. Zero with an arrow on top to denote that it's the zero vector. Okay? Because the curl always outputs or always gives a vector. So it is incorrect to say that it is only zero, but the zero vector. It should be the zero vector. A vector's components are all zero. Okay, and then let's recall also how to obtain the gradient, how to obtain this gradient here. Okay, so the gradient of some scalar field phi when we are working in two dimensions or on R2 is the following. Okay, so this is the vector containing the partial derivatives. At the first component, this is the partial derivative of phi with respect to x. And in the second component, this is the partial derivative of phi with respect to y. So, and then for three dimensions, the gradient is given by this vector with three components whose whose first component is the partial derivative of phi with respect to x, and then the second is the partial derivative of phi with respect to y, and then the third is the partial derivative of phi with respect to z. These are easy to remember because they are aligned on what we are used to about ordered pairs and ordered triples. So x sa first, y sa second, then pag three dimensions, z sa third. Okay? So with that, we proceed to the next problems here. Okay. So we determine if each vector field is conservative. Okay. So first step, let's declare some variables here. So let p be equal to this function, and then q to be equal to this function here. Okay. So this is simply the first component, and then this is the second component. Okay. So since this is a vector field on R2, we have a simple test to determine if the vector field F is conservative, which is given by this one. Okay? From this point onward, for the sake of brevity, I shall say the partial derivative of q with respect to x as qx, and the partial derivative of p with respect to y is py. And then all similar structured notation will also be applied. I mean, kung ano yung kung paano ko pagkabigkas dito, ganun din sa sa susunod. Yung parang katulad din nito, okay? So, this is simple, okay? So we get the partial derivative of the second component with respect to x, and then yung first with respect to y. Okay? So parang binaliktad lang. So ito kasi yung karaniwan, 'di ba? This is the usual sense, no? Ito yung x, ito yung y, parang x position, y position, then parang cross lang, parang ano lang, palatandaan lang, okay? Some ano lang, technique to remember, okay? So, by computing the partial derivatives, we obtain this, okay? Hopefully, you still know how to compute for partial derivatives. Otherwise, you may refer to our previous videos about partial derivatives. Okay? So notice that they are equal. Therefore, f is conservative. Okay? Next. So, this is a two-dimensional vector field now. Okay? So, same logic as the first one. We let p to be the first component and q to be the second component of f. So, we get py and qx. Okay? Now, let's recall again, no? The derivative of the natural logarithmic function, say ln of something, is 1 over something. And chain rule will apply whenever possible. And the derivative of tangent inverse or arctan of xy, or actually anything, sige, derivative of the arctangent of anything is 1 over 1 plus anything squared. And then chain rule. Okay? So, ayan. And then, ayan, simplifying ditong part na to, ayan, cancel lang. So, we have this one. And then, likewise, simplify, we have this one. Now, note that they are almost equal. Oh, sad. Muntik na. Okay. Muntik na. Ayan. Nagkaiba lang dito. Slight difference here. Okay? So, they're not equal. Therefore, not conservative. Okay? So, ayun. Pag di nag-equal, hindi conservative. Pag nag-equal, conservative. Okay? Next. Okay, for this third one, this is a three-dimensional vector field. So let P, Q, and R be the following. And since we cannot simply apply Qx equals Py, that relation there, we will resort to the theorem that I mentioned a while ago, which is the curl of F is equal to the zero vector. Okay? So, specifically, okay, we give a more descriptive version of this curl, this condition, this curl F equals the zero vector. Okay, so we assume that F is of the form, the three-dimensional vector of this form, where P, Q, and R are scalar fields with continuous first-order partial derivatives on a simply connected region. Dami sinabi, no? Ako, basically, there is existing lang yung continuous first order partial derivatives. Bale, legal move naman partial differentiate dito mga to on a given region. Don't worry, the given functions here and hopefully in your respective courses are assumed to be have assumed to have continuous first order partial derivatives on simply connected region. Okay. So here, recall, we compute the curl this way. So remember that this del operator here, okay, this is, since we're dealing with 3 dimensions, this is just a vector containing partial derivative operators. Okay. So with respect to x sa una, with respect to y sa second, and then with respect to z sa third, sa pangatlo. Okay? So, ayan. Now, since this is the cross product, okay, meron tayong ganito. We have this. And let's recall how to compute such, okay? So, we cover up the cover up method tayo, Okay, cover up the first row. And for the first component, we just somehow multiply, similar to multiplication. Okay, so this becomes ry, or partial derivative of r with respect to y, then minus the partial derivative of q with respect to z. Okay, and then for the second one, let's be careful here on the second one. So partial derivative of r with respect to x. Okay, let me write this down. Okay, minus partial derivative of p with respect to z. P with respect to z, but we apply minus sign in front. So multiply by -1. Okay. Anyway, this only applies to the second component of our curl to obtain our second component for the curl. Now, for the third component, okay, partial derivative of q with respect to x, and partial derivative of p with respect to y. Ito muna, minus. Ayan, ito. Okay? Qx minus py. Okay? Now, if you're familiar with linear algebra, this is just a cofactor expansion along the first row. Okay? So after that, we obtain this. Now, since we require f to be conservative, I mean, it is given that f is conservative, we require this. So this means it should be equal to the zero vector. And when are two vectors equal? If their components are equal. Okay, so equal dapat to, equal to, and then equal to. Okay, isolating one of those terms, we obtain this relation. Okay, now I don't advise you to memorize this, of course. Uh, Rather, it is advised that you understand how this was obtained. Okay. Anyway, hopefully you still know how to compute for the curl. But if not, you may also refer to our previous videos about curl, how to compute for the curl. Okay. Now this is just the second dimension case. So a vector field in two dimensions. Well, you may also do this, pero you set r to be 0 so that you have 0 here, then 0 here, and then, ayan, ito matitira. Kaya ano lang, kaya pagdating sa R2, two-dimensional vector field, Qx equals Py lang. Nire-require para maging conservative. Okay? So we compute for these six. Okay? So, partial differentiation lang tayo. Ayan. Okay. So, remember the derivative of secant is, okay, kasi dito, ano, no? Secant squared uh, x plus y. So you may think of that as, ano naman, you may think of that as secant of x plus y, then you will square it. Ayan, then apply chain rule lang. With recalling the fact that the derivative of secant of anything is secant anything, tangent anything. I mean, secant of something is secant something, tangent something. Okay? Derivative ng sectant. Yan, palatandaan lang. Okay? Since they are equal, itong pair ay equal, itong pair, and then itong pair. Okay? Or equivalently, their differences are 0. So mag-equal to 0 yung pag sinubtract. Equals 0, equals 0, equals 0. Pag subtracted, sige, nagsisingit lang eh. No? Okay? Ayan. That means the curl is 0, and therefore, f is conservative. Okay? Ayan. Since equal sila, f is conservative. Okay? Note that not all 6 should be equal, kundi yung required pairs lang naman. Ayan, ito. Or yun, basta pag hindi nyo tandaan to, curl is equal to the 0 vector. Yun lang naman. Okay? So pag hindi 0 vector, hindi conservative. Okay? Now, next, for the second set of problems, sorry, ayan, give all potential functions for the given conservative vector field. Okay? So, sabi natin, di ba, pag conservative, meron tayong makukuhang scalar field such that yung gradient ay equal to f. Okay? So we can find a scalar field such that its gradient is equal to f. So what we do is we let phi to be our potential function for f, and so the gradient of phi is equal to f. Specifically, yung components dapat ni f, the components of f are partial derivatives. Okay? They are partial derivatives. So we have the following. Okay? Then, we wish to obtain phi. So, how do we do that? Since they are derivatives, we do the reverse process, which is integration. Ito, pag ginamit natin integration with respect to x, ito integration with respect to y. However, the slides are already preset, Wala tayong magagawa dyan. So, gawin na lang natin yung sa x. Okay? So, that means we partial integrate or integrate with respect to x. Okay? Partial integration, parang ganun. Okay? So, that this will yield this one. Okay? Note that not only a constant c, but a function of c alone. Okay? Function dapat. Bakit? Kasi if we differentiate this with respect to y, partial differentiate this with respect to y, this should be the result. Okay? And since we are talking about partial differentiation with respect to x, all functions of y are treated as constants. Okay? Okay, so now we have this temporary phi. However, kung ano na sa given, dapat as much as possible magagamit natin. What's given in the problem, as much as possible, should be used, okay, in our solution, should be involved in our solution. So that means let's try to differentiate phi with respect to y, partial differentiation with respect to y. So this will yield this one, okay? Now note that this can be c prime kasi this function is of y alone. This is partial differentiation of with respect to y. With respect to y tayo. So, pwede naman prime. Parang ordinary differentiation lang naganap. It's like ordinary differentiation, okay? And then we compare, okay? So, let's see, ayan. Spot the difference. Kung magaling kayo sa where's Waldo, sige lang. Easy na to sa inyo. Joke lang. Okay, so we have an e to the 2x and then minus 14x squared y. So, merong invisible zero dito, magtatago, sneaky. So, this means c prime of y is equal to 0. So, that means by integration with respect to y, so reverse process lang again if we want to get c, this will yield k for any constant k, any real number k. Kasi 'di ba derivative ng constant ay 0. Okay? So, we have phi to be this one. So this is our potential function. I mean, all possible potential functions. So, any potential function of f is of this form, where k could be 0, could be 1, negative 2, 10, 69, 420, or negative 1337, or 1 over 2048. Naisip ko yung sa shiny Pokemon chance eh. Anyway, so ayun. This is the form of all possible potential functions of f. Okay? Next, let phi be a potential function for f. I mean, our given there, okay, by rewinding this YouTube video, is a three-dimensional vector field. So it's conservative. That means its components are all partial derivatives. Okay, so we have this set of equations, and then by following the same logic with a bit of an extension though, because we are dealing with an additional variable, z. So we integrate with respect to x muna because of this one. So we partial integrate with respect to x, integrate with respect to x. So we have this one. Again, this is a function of c of y and z alone, because if we take the derivative with respect to x, partial derivative with respect to x, this should be the result. And this is treated as a constant, because again, this is partial differentiation with respect. We are dealing with partial differentiation here with respect to x. Okay? So now, we get the partial derivative of phi with respect to y, which is this one. Okay? And then compare. So, loners naman sila pareho. nag-iisang terms, only one term. So, that means C, cy of yz is equal to the natural logarithm function there. And then we integrate, and let's undo the process, do the reverse process. So, integrate with respect to y, this will yield ayan, this one, this expression here. Okay, again, function of z, because we are dealing with respect to y, yung ating integration, and then yung pag for checking yung reverse process, partial differentiation ito with respect to y, this should be the result. Ito kasi constant naman when we are dealing with partial differentiation with respect to y. So ayan, then plug in natin sa phi, we have this one. Okay? And then di pa natin nagagamit yung ano no, yung phi z. We haven't used the partial derivative of phi with respect to z. So let's partial differentiate with respect to z. So this will yield this one, okay? Prime, okay, pwede ng prime. Pwede ng prime notation kasi this is a function of z, and we partial differentiated with respect to z. Okay? Match lang naman. Okay? And then by comparing plus backtracking of this YouTube video, we obtain d prime of z equals 3z squared, and by undoing the process, we get z cubed plus k for any constant k. So this means our potential function, any potential function of this vector field is of this form. Okay? And lastly, yan, yay! Last na. Okay, so our potential, we need to find a potential function, potential function, okay? Take note, as opposed to the previous problem which required us to give all possible potential functions. So this problem just means, okay, after obtaining all possible potential functions, kung ano itsura, what should it look like? We give a specific value for k afterwards. So this is what is required of this problem. Okay? You find the potential function for this vector field. So same logic as the previous one. So let phi be a potential function for f. Then the components are all partial derivatives. Okay? So we have this set of equations. And we obtain phi. So we integrate with respect to x muna kasi nga nakaset na yung slides. So we have this one. Okay? Okay ha, ingat tayo ha. Let's recall natin ang integration techniques. No? This was obtained by integration by substitution. And then we take the partial derivative of the previous equation with respect to y, which is this one. Okay, ingat sa notations natin. And then by comparing 9 and 11, this one and yung kanina dun, we have this expression, this function. Okay? So kasi this is kanina kasi this is a function of y and z. So if we obtain partial derivative with respect to y, eh may y sa loob, so ayan, ganito notation, okay? So ito ngayon, doing the reverse process, we obtain this one, and then we substitute it back. So para mabilis mag-backtrack, so you can conveniently backtrack and still recall what you're working on. So we have this one. So natitira na lang ay partial derivative of phi with respect to z. So we attempt to do that. So we have this one. Okay? And then compare. We have d prime of z equals ln of 3z. And then let's integrate this, undo the process. We have this one. Oh my gosh, ano nangyari? Okay? Okay. Let's kalma lang tayo. This is integration by parts, and hopefully naalala nyo pa to. Hopefully you still remember how to do this from your previous calculus courses. Okay? So, so now we have our potential function, the general form of our potential function. Okay? However, as I said a while ago, we need to find a potential function, a single potential function. Okay? So so here for convenience, we set k to be equal to 0. Para madali na. And so we have this one. Okay? Depends on who will check your work. Um, Probably he or she will require you to use a different name for your specific potential function. That's why it was put here as phi sub 0. But if kung hindi naman sobrang stricto, pwede naman drop na to. Tapos, ayan. Pero for the sake of being proper lang, using proper notation, ayan, iniba ko lang pangalan. Okay? So, basically, ang nangyari lang dito ay pag magso-solve tayo ng ganitong problems, all we do is differentiate, okay? Integrate, and then compare. Okay? Differentiate, basta differentiate muna, partial differentiation, and then integrate, and then compare. Compare. Kung ano mang mangyayari. Okay? Para unti-unting pupunta sa potential function. Diba? Parang roller coaster ride lang. Ulit-ulit ka lang. Okay? So, this ends our review on this topic, conservative vector fields. So, thank you very much for listening and hope you have a good day or a good evening.